All right, we are on our last section of material for test 2. And we're running down period. We only have 6 sections after this. Just 6 sections on test 3. Okay. Again, the stuff we're doing today is going to be similar to 8.1 and 8.3. We're just making a little bit of an adjustment. Here, there you go. You're welcome. And the adjustment we're making today is that we're not estimating a population mean anymore. We're going to look at a different parameter that we haven't seen yet, called a proportion. So the proportion part of this is the new part in this section. Okay. So all a proportion is, it's just a fraction. Okay, so if we have some characteristic we want to know about our population, okay, so maybe I want to know what proportion of the people in this room, their favorite pizza topping is pepperoni. Okay? And all we would do is we count how many people that have that characteristic, how many people that's their favorite pizza topping, out of how many we have in total. So we just get a fraction. Okay? That's all a proportion is. Most of the time it's going to be easier for us to write them as decimals. Okay, so we'll see that, but that's all we're dealing with here. Okay? We're going to make confidence intervals for these things. Okay? So, kind of already gave you part of this here. We're estimating a population proportion. Okay? And our population proportion, our symbol for that is a lowercase p. I don't particularly like that, but that's what our textbook author has gone with, and that is used sometimes. Sometimes instead of p, which this is confusing too, but sometimes instead of p, you'll see people use pi, okay? Greek p. Our text uses a p, okay? And it's just a fraction or a percentage of population that has some certain characteristic that we're looking for. Okay? So just like with means, if we can't take a census for some reason, okay, then we're not going to directly calculate p. Okay? What we're going to do instead is we're going to take some sample data and use our sample data to come up with an estimate for our population proportion. Okay? So same big idea we had when we were doing this with means. Okay? Can't directly calculate because we're not going to take a census for some reason. So we just collect some sample data and we're going to make an estimate. Okay? Okay, so if we're doing that, so P is our population proportion. Okay? Our parameter tells us about the whole population. If we take sample data and we calculate a proportion from our sample data, okay, we get a sample proportion, and our symbol for a sample proportion is a P symbol, and we have this little rooftop looking thing on top of it. The way we read that is we just call it P hat. Okay, so we've got X bar and now we've got P hat. Okay, so there's our sample proportion. Okay, so same idea, we're just dealing with sample data. Okay, and we've got a little formula slide. We really don't have to have a formula, it's just the number of data values that have the characteristic we're looking for out of the total number of data values. So that's all this says too. Okay? It says if we want to calculate a sample proportion, it's X over N. N is just our sample size again. And then here X is the number of data values or the number of individuals if we're thinking about people that have whatever characteristic we're looking for. Okay? So X is the number of data values we're counting, N is just the total. Okay. Get our sample proportion that way. Okay. So let's practice. Okay, since we haven't worked with proportions before, let's find a sample proportion. Okay, there's not too much to it, but it is new. Okay, so let's look at one of these. It says a graduate student wishes to know the proportion of American adults who speak 2 or more languages. He surveys 565 randomly selected American adults and finds that 226 speak 2 or more languages. Estimate the proportion of all American adults who speak 2 or more languages. So we've got 2 things we're kind of combining in this problem. Okay, remember, if we want to make a confidence interval, our step 1 is we have to come up with a point estimate, a starting place for our interval. So with means, we wanted to estimate a population mean. Our point estimate was a sample mean. Here, if we want to estimate a population proportion, okay, our point estimate is going to be a sample proportion. Okay, so same idea as the last stuff we've done. We're just dealing with proportions instead of means. Okay, so here, when it says estimate proportion of all American adults who speak 2 or more languages, that just means we're looking for a sample proportion. It'd be our point estimate. Okay, so calculate our sample proportion here, p hat. Okay. So x over n. So x, number of data values we have that have the characteristic we're looking for. What people are we interested in on this one? People that speak 2 or more languages. Okay. And how many of those do we have? We've got 226 of those. Okay. Out of how many people were in our survey? 565. So not a lot to it. Okay. That's what's going on. It's the number of people we're interested in, the ones we have the characteristic we're counting out of our sample size. Okay. One quick tip here. Okay. The bigger number is always going to be on bottom. Okay. You can't have more people that have a characteristic than you have people in total. The bigger number is always on the bottom here. And then here we could write that as a decimal. So we could do 226 divided by 565. This one comes out nice. It comes out to exactly 0.4. Okay. So either the fraction or the decimal is okay there. That's all there is to finding a sample proportion. Questions? Anybody else need tables? Got a few more up here. Everybody get them here? Did you come in? You're good? Okay. Good deal. All right, so that's a sample proportion. Okay. So you probably have not had time to think about it yet. Okay. But what kind of data distribution are we dealing with here if we're thinking about proportions? Let's think about that for a second. So if you're on this one, if we're looking at American adults and we're counting how many speak 2 or more languages, well, what we're doing is we're splitting the data into 2 categories. Right? We've got people that speak 2 or more languages and people that don't. Okay? So as we go to each person in our data, they either speak 2 languages or they don't. So we only have 2 possible outcomes. So really, if we're dealing with proportions, we're working with a binomial distribution. Okay? But okay, here's a little good news. All right, so binomial distribution, just a quick reminder, you don't have to write all this down again. Okay, but that's when each trial is independent of the others. We only have 2 possible outcomes, right? It's chapter 5, right? 5.2, that section. So technically, okay, what we should be dealing with when we're estimating these things is the binomial distribution. Okay? But here's some good news. Okay? Here's some good news. If we have certain conditions, instead of working with the binomial distribution, we can estimate this thing with the normal distribution, okay, the z-table. Okay? So if we're in the right conditions, a binomial distribution is symmetric and bell-shaped. Okay? So the conditions we need come into our formula here for finding the margin of error. So again, remember, we need two pieces of information to make a confidence interval. We need a point estimate. We just dealt with that, the sample proportion. And we need a margin of error. Okay, so that's what we're looking at next. Right here. It looks a little ugly because it's got a square root, but it's not bad. Okay, but before we dig into the formula, let's look at this part. Okay, so it says our sample needs to be a simple random sample. That's been true the whole time. We've just kind of been ignoring it. Okay. But here, if the conditions for a binomial distribution are met, and that happens when we're working with proportions, okay? And here's our two conditions. We're not necessarily saying we need a sample size of 30 here. We're saying if we multiply our sample size times our sample proportion, it should be 10 or bigger. And if we do our sample size times 1 minus our proportion, that should be 10 or bigger. Okay? If that's true, those are our conditions we need to use the normal distribution instead of having to deal with those binomial tables. Okay. Luckily, that's not too difficult to get unless you have like a very extreme p-hat, unless p-hat's like 0.99 something or 0.01 on one end of the spectrum or the other, then that's not too bad. So we're not going to worry about it too much. Okay. Then here's our margin of error. Okay. So it's not bad. We start off with the critical z. We've already talked about how to find those in 8.1. It works exactly the same. Okay, you just look for a confidence level, and then we've got that little cheater table we use, okay, to get our critical z. And then the rest of this is all under a square root. Okay. So we've got our sample proportion times 1 minus the sample proportion divided by the sample size. We take the square root of that, multiply by our critical z. It is a little annoying because we've got that square root in there, but it's not a bad formula to do. Okay. That's our margin of error. Okay. I said we're not going to be too concerned about checking these. Right? Like we didn't spend a whole lot of time focusing on our sample size being 30. Right? We mentioned it here or there, but let's do one just where we check a couple of situations to see if this would work or not. Okay. And then we won't really worry about it after that. Okay. So let's see. So it gives us two conditions again. We want to check to see if those two conditions hold in these two cases. Okay. So on A, what we would need to check, it gives us n and it gives us p hat. Okay. So we would need to check that 45 times 0.18, that needs to be at least 10, but if we check that one, and it comes out to 8.1, so that would not be quite big enough, okay, for us to use the normal distribution instead of the binomial. So on A, that situation would not be qualified to use our margin of error formula we just saw. Okay, we'd have to use something different. But if we check on B, okay, so here we've got 90 adults, so N is 90. Okay, 34 have had the shingles vaccine, so we could figure out p hat. That would be 34 out of 90. So what does that give us? It gives us a p hat of, if you round, is 0.378. Okay, so then if we do 90 times 0.378, we get there, 90 times 0.378, it's like about 34. So that one's big enough. And then we would need to do 90 times 1 minus 0.378. Okay. That one would definitely be big enough. That's what we would do if we were chicken. That's about 56 there, so both of those would be good. Okay. First one would not. But we're not going to worry about it from past this slide. Okay. You can just assume the ones we're going to do, you can use with the normal distribution. Okay. If that doesn't work, okay, you got two options. You can either increase the sample size in real life, right? You would draw a bigger sample, because here on A, if you draw a bigger sample, you'll have a bigger number to multiply by to get to 10. Or most of the time in practice, if we're using like a computer to run the statistics, we don't really care that the binomial's messier than the normal distribution, because the computer's going to do the work. So we'll just go ahead and use the binomial distribution, and it's not that bad. But since we're doing these by hand, all the ones we're going to do with the normal distribution. Okay. Okay. So let's back up. We can find our point estimate, p hat. Right, it's x over n, the ones we're counting out of the total. We can find the margin of error. Okay. So critical z times the rest of this. And critical z we can deal with. Not that big a deal. So we're ready. Okay. We're ready to make a confidence interval. And we've got the two components we need. The last step, let's look at the last step here. It looks a little bit different here because we're using p hat instead of x bar. X bar is a sample mean. Here we're using a sample proportion. But it's the exact same idea. We take our point estimate, add the margin of error, and subtract the margin of error to get the two endpoints on our interval. Okay. So no big deal. All right. And hopefully you can kind of see the benefit of learning about these confidence intervals, because even if you go on and you're doing a confidence interval for some other type of parameter that's not a mean or not a proportion, hopefully you can see picking up this proportion stuff is easier now that we've done the ones for the means. Right? You get the big idea, and then learning a new type's not really an issue. And you just tweak a couple of little things and it's not bad. All right, so let's do one. We do have a little rounding rule here that our book uses. It says when we're dealing with proportions, we're going to round our final answer to 3 decimal places, just our standard. Okay. So let's do one. Okay. All right, so this one says a survey of 345 randomly selected students at one university found that 301 students think that there is not enough parking on campus. Okay. Find the 90% confidence interval for the proportion of all students at the university who think there's not enough parking. Okay. So step one, we need point estimate. Since we're dealing with proportions, our point estimate is going to be a sample proportion, p hat. Okay, so what we want is we want p hat. That's the ones we're counting out of the total. So here we want the ones that think there's not enough parking. So how many of those do we have? 301 out of 345. Okay. So all there is to that. So 301 out of 345. That is an acceptable answer. But since we're about to use this thing in our margin of error formula, you could put it in as a fraction. Okay, nothing wrong with that. It's a little bit more aggravating to put in the calculator that way. So let's change it to a decimal. So 301 divided by 345. Okay. Since we're going to round our final answer to 3 decimal places, we want to leave more than that on our sample proportion, okay? So we don't get rounding error. So I'm going to leave, I guess I'll leave 5. Okay, let's leave 5. So that'll be 2 extra. So that'll be 0.8724 6. Okay. Textbook says leave 6. Okay, that's overkill. So there's p hat, our point estimate. Step 2, in margin of error, let me write the formula down again. So it's critical z times the square root p hat times 1 minus p hat divided by n. P hat we just found. N was 345. We had to use that to find p hat. So the only thing we're missing here is our critical z. Okay. Critical z, here's a refresher from 8.1. We look at our confidence level. It says we want to be 90% confident. So we take our confidence for z's and go down to the bottom of table B, at that little cheater table. So we want C to be 90% or 0.90. So what's our critical Z going to be on this one? 1.645. And I know it's been a while since we've done one of these, but just right down here, the little mini table. Okay, that's all the information we need. And we just plug into our formula. Okay, so we've got 1.645 times the square root of p hat was 0.87246. I think Hawks lets you round the sample proportion to 3 places, so makes it a little less messy. Times 1 minus that number. And then we're going to divide by the sample size, which was 345. So if you've got your calculator, you might want to try punching this one to make sure you can get the right number out of it. Okay? So what I do is I do the part under the square root first. So I'm going to do 0.87246 times 1 minus 0.87246 divided by square root of 345 to get that number. It's like 0.00599 something. And then I'm going to take the square root of that answer and then do times 1.645. Okay, so here, margin of error rounded to 6 decimal places is 0.127 323. So I do this part underneath the square root, take the square root of that answer, and then multiply by 1.645. That's how I do it. Okay. You can type it all in just like it's written, but I don't like having to mess with all those parentheses. Okay. And then the last step's the easy step. Okay. So we got p hat's 0.87246. That's p hat. E here is 0.127323. So we're going to add those one time and subtract them one time to get our two endpoints. And then remember, we're going to round our final answers to 3 decimal places. So 0.87246 plus 0.127323. I get 0.9997. Making sure. Okay, that's just a little weird number, so wasn't quite expecting. So I get 0.9997. So this one rounds up to 1. That's unusual. And then when we subtract, there I get 0.745. Okay, so my interval, if I make it into an interval, I get 0.745 to 1.000. I say that's unusual because that's the maximum you can get. Right? 100% of people is maxed out. So here I'm 95% confident. And so we're dealing with, think there's not enough parking, right? These are proportions, so you can write them as decimals, but you can also think about them as percentages. So we could say we're 95% confident that between 74.5 and 100% of people think there's not enough parking on campus. Seems like that's something they need to deal with. Kind of similar to here. Did anybody else get a different number on margin of error? Anybody check me? I'm questioning myself. Let me punch it one more time to make sure I didn't mess it up. Okay, that's good. Okay, it's just unusual. Okay, don't expect you're going to get 1 on the end most of the time. It's not unheard of, it's just uncommon. Okay. Questions on that one? Yeah, I did. Yeah, I did 0.87246 times, and then did parentheses, 1 minus 0.87246, close my parentheses, divided by 345. Let me see. Make sure that's coming out right. Oh, okay, I see what I did. I did mess up, I'm sorry. That's why you gotta punch it and make sure I'm doing it right. Okay? Can't just trust the teacher. All right, so what I was doing, okay, hang on, let me get the right answer. Square root of answer times 1.645. Yeah, so what I was doing on accident, okay, this is my first one this semester too. Okay? What I was doing on accident is I was doing this times this divided by square root of this, and then taking the square root of the whole thing. So I was getting my square root getting ahead of myself with the square root. Okay, so this number times this divided by 345, and then take the square root of all that answer, and then multiply by 1.645. So on that, it should come out to 0.029543. So if you got that and you thought you were doing something wrong, you didn't. Okay. now we got to fix the next line. I thought that was fishy. Okay, I just couldn't figure out what I was doing wrong. We got to change that to the proper margin of error. So 0.29543. Okay, so let's try that one. 0.87246 plus 0.029543. Yeah, it looks more reasonable. There we get 0.902 for the upper. And 0.843 for the lower. That should be right. Sorry about that. At least you get to see math teacher messes up too, right? Okay. So now we're 90% confident between 84.3% and 90.2% of people think there's not enough parking. So that seems more reasonable. Other questions on that one? Thanks for asking your question because it helped me realize what I did wrong. Anything else? Okay, so the new parts, we've just got really just two little new pieces. Right? So we've got the finding p-hat, finding the sample proportion, if it doesn't give it to us directly. And then new margin of error formula. That's just plugging in. We already know how to find critical Z. So not too bad. And then we take those two numbers, just like we have done on the other ones, and add one time and subtract one time to get our endpoints. Okay, let's do another one. Let's see if we get first try this time. That's step 3. Look at this one. This one's given to us a little bit differently. So it says, in a recent study, 820 American adults were surveyed, and 61% said they would travel less this year for non-business trips than last year. Find the 95% confidence interval for the true proportion of adults who said that they would travel less this year for non-business trips. So the big difference on this one from the last one, we don't have to calculate p-hat. It gives us the sample proportion. So this one says 820 American adults were surveyed, and 61%, that's saying 61% of those in the survey said they would travel less this year. Okay. So p-hat is just 61%, or as a decimal, 0.61. And so we don't always have to calculate p-hat. Sometimes it's given to us. Okay, so there's step 1. Okay, step 2, need to calculate margin of error correctly this time. Okay, so we've got p-hat, we need critical Z, and we also need to pick out what our sample size is. We haven't had to do that yet on this one. So it says we had 820 adults in our survey. That's our sample size. For our critical Z, look at our confidence level. So 95% or 0.95 for our confidence. What's our critical Z going to be this time? 1.96 off of that little cheater table, okay? The little mini table. So now it's just a matter of plugging into the formula. Okay, so 1.96 we just found times the square root 0.61 times 1 minus 0.61. If you want to do that little step ahead of time, you can. Okay? Be 0.39, that's okay. And then divide that by 820. It's our n. On this one, let's see, so 0.61 times 1 minus 0.61 divided by 820. I get 0.00029 something. Okay, take the square root of that times 1.96. Get our margin of error and out to 6 decimal places. I got 0.0333. A lot of threes on that one. 85. Okay. Okay. Our part's over. Now we take our sample proportion, 0.61, and we're going to add our margin of error. One time. We'll subtract our margin of error one time. These are always going around to 3 decimal places at the end, so 0.61 plus 0.033385. Get 0.643. 0.61 minus 0.033385. It rounds to 0.577. There's our interval. We're 95% confident that between 57.7% and 64.3% of people will travel less this year for non-business trips. Okay. Questions on that one? You getting tired of confidence intervals? Starting to? Yeah, me too. One more, we got one more and then we'll be done with them. Okay, won't have to do any more in class together. Okay. Hopefully if you're getting tired of them, that means they're getting easier. So okay. One more, this one's out of Hawks. It's a little, it words things a little tricky, so I don't want us to look at this last one. Okay. Let's look at this one. Okay. You do have to be careful reading these, okay? Because remember, X is the number of data values that have the characteristic we're counting. Okay? That's how we get our sample proportion. So it says an environmentalist wants to find out the fraction of oil tankers that have spills each month. Suppose a sample of 262 tankers is drawn. Of these ships, 202 did not have spills. Okay? You do have to be careful there. So we want the ones that have spills. It gives us the ones that did not have spills. And that tells us to estimate the proportion of tankers that had spills, asking for a point estimate or sample proportion p hat. So if we want the ones that have spills and it gives us the ones that do not have spills, what do we have to do to get our top number? Subtract, yeah. So we want X over N, but X is the ones that did not have spills. So we got to do 262 minus 202. So we'll have 60 on the top out of the 262. And it gave us the opposite of what we wanted to have to subtract. So then we can, that's fine, we could give our answer 60 out of 262, but we could also round it. It says round it to 3 places, so 0.229 p hat. Okay. And then step 2, it's going to get us to finish out making the interval. Okay, so step 2, it gives us the same information, but this time it says construct the 85% confidence interval. So he had, what was it? 0.229, and we're going to need that. Okay. And then it says we want 85% confidence. So we can get our critical Z that way. Critical Z here is 1.44 off of our little table. So then let's get some more room here. Our margin of error, 1.44 times the square root of 0.229 times 1 minus 0.229 divided by the square root of our sample size, which was 262. So let's see. That one I got 0.037382. And then we want the interval on this one, so we've got to add and subtract. So okay, let's see, 0.229 plus. Get 0.266. I do minus. Get 0.192. So those are the two numbers for our boxes on Hawks, but we could write it as an interval. Okay. Alrighty. Questions on that one? Feeling okay about confidence intervals? So? Okay. I got about half nod yes and about half blank stare, so that's pretty normal, I guess. All right, well, that's it. And that's all for test 2. All right, so Thursday, okay. Thursday, we're gonna do a Hawks day. So this Thursday, if you want help with Hawks, or you just want to have somebody in the room with you to encourage you to work on Hawks or whatever, okay, we'll do that during class time. If you're caught up on Hawks or you don't want anybody messing with you when you're trying to work on Hawks, whatever, okay, you don't have to come, that's fine. But I will be here to help, okay, and some of your classmates will be here working together, so. Okay, so just come if you want to. Come if you want help.
When will you post like
The
test?
practice test, probably tomorrow.
Okay.
Yeah. Okay. So next Tuesday will be review day. Next Thursday will be test 2. Yeah. 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 Okay. All right, that's it. If you didn't get on the sign-in sheet, make sure you get on there before you leave.